Hello, second years. Now, I've been getting emails from a good clattery about um, the how to design an experiment and possible ideas for a CBA. So I'm going to help you here, guys. Now, the first thing with an experiment is you have to work out. Sorry, let's get my pointer pen here. Uh, you have to decide on your variables. So there are three types of variable. You have the independent, you have the dependent, and you have the controlled variables. Now I realize that's kind of like oxymoronic, it contradicts itself, but we'll talk about it in a second. So the first thing is the independent variable. So that's the I change. I, independent I change. So you can only change one variable at a time. And I'm going to go through an example of it, guys, of how you can only change one thing, okay, in an experiment. You can only change one thing. Your dependent variable depends on what you change. And basically that's your results. Your dependent variable ends up being your results. Now, your control variables is everything that could possibly change, but we try and keep the same. Okay, so there are three types of variable. Independent, that's what I change. That's the factor we're investigating, if you will. So, like, very simple one would be if you were judging the time taken to boil potatoes and how small the pieces are. So the size of the pieces of potato is what you're varying. Okay, your result would be the time taken for it to cook, and your controlled would be, for example, the amount of water, the temperature, you know, the size of the pot, etc., etc., etc. So, that'd be a very, very simple version of it. And some people have been getting it and sending me the good ideas, but some people aren't too sure. So I'm going to bring in this sheet here, and this is an experiment we did, guys. So it's done where we studied the effect of concentration on the rate of reaction. Now, that's meant to be an eyeball there. Okay, so it's when we reacted the sodium thiosulfate with hydrochloric acid. Remember, we had the conical flask, and then the cloudiness got produced, and we watched to see until the X disappeared. So the independent variable. So we changed the concentration of the sodium thiosulfate. And if you remember, I went around the room and some people had 20 centimeters cubed, some people had 10, some people had 30, etc. of the sodium thiosulfate. Okay? So that was what we varied. And then we added water to it. Now, the reason we added water to it, and I'll come to it in a second, up to the same volume. So we had a constant volume. So I think it was some people got 20, some people got 30, 40, 50, 60. And we made it up to 100 centimeters cubed. Okay? The reason we made it up to 100 centimeters cubed, or it might have been 50, I can't actually remember what we did. But either way, the whole point of doing that was so that the volume in the container would be constant. Okay, so it would be controlled. That'd be a controlled variable that we had to control. So the only thing we changed was the concentration of the sodium thiosulfate. And based on that, our dependent variable, based on changing the independent variable, is the time taken for the X to disappear. And then we did some data analysis and we were able to calculate our rate. But ultimately, the dependent variable was the time taken for the X to disappear. Okay, until you couldn't see it. Now, your control variables, they're all the things that you have to control. So we had to control the temperature. It was always at room temperature. We had to control the volume, and I just described that. Remember, we made them always up to the same value. The same person looking at the X. The X had to be the same size on every single person's table, because, and have the same person looking at it, because, I might still be able to see the X, but Johnny mightn't be able to see the X, or Mary might be able to see the X. So, the same person has to look at it, and they make the call, okay, I can't see the X anymore, we're done. Okay? With regards to the hydrochloric acid, the volume of the acid was the same, and the concentration of the acid was always the same. So, guys, when you're designing your experiments, keep them simple. Changing one thing, measuring one thing. Okay? So in this example here, we changed that, we measured that, and we kept all these things the same. So we changed the concentration, we measured the time, and we we try to control as much as we possibly could. Okay, so these are very, very simple experiments you could do, guys. Very, very simple experiments you could do at home. Like you could, I gave one example there of the size of potatoes, how long they take to be cooked. If you cut them into big chunks, small chunks, whatever, And once you go through it and explain, and you're able to explain why you got the results you got, that's 90% of the battle. So lay it out just like you would, a normal experiment, except in your results, include in your results a little subheading called data analysis, where if you have numbers, you can mess with them. Okay. So for example, someone suggested an experiment on the effect on heart rate. Well, there's no point in saying the heart rate was 50 or 100, after this exercise, 120 after this exercise, etc. What you should do is say the effect of the heart rate. So in that particular case, for your data analysis, and again to get your maximum marks, show a bit of maths skill, for want of a better phrase. So what you'd need to do there is you'd measure the resting heart rate, measure the heart rate after, and then calculate the effect by subtracting the resting heart rate, which is the small number, from the elevated heart rate, and then you're able to work out the effect. Okay, because it's just that's what you're measuring. You're measuring the effect. Okay, things like that. I mean, keep the experiments very, very, very simple, guys. Keep the experiments very simple, very straightforward. I mean, it could be something like bouncing a ball. What are the factors that affect the height the ball bounces? Things like that. Very, 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 very simple things, guys. The car one running it down a ramp is, again, a very straightforward one. Pick something that you're going to alter and pick something that you're going to measure. They're the two things you have to do. So pick something you're going to change, pick something you're going to measure. If anyone has any questions, guys, please feel free to contact me either on our Teams or send me an email. Just remember, something you can change, then something you can measure. Something you can change, something you can measure. Okay, and then do a bit of finagling with your maths and your results, plot a graph, things like that. That's how you're going to get your top marks. Okay, folks. If there's any questions, please stay safe, mind yourselves, and we'll talk to you soon. Bye bye.